So I guess we all are back to main room.
Yes, ma'am.
Okay, so we'll start with the Kaplan-Meier, and that cumulative probability we have not touched yet. So I will explain that here, the cumulative probability, because I have told you regarding the median survival time where there was a concept of cumulative probability, but we have not covered that. So we will again learn that in this session, and then we'll again go back and do the Kaplan-Meier survival. Then probably you will understand in a much better way. So this Kaplan, so till now you have done the survival analysis using the life table approach. But again, I told you that there is a limitation of life table, and it is not a very common method of analysis which is done by everyone. So the more common adopted ones are the Kaplan-Meier survival and the Cox proportional hazard regression model. So now what is a Kaplan-Meier survival analysis? So in the beginning, you have understood regarding that there is a survival probability and there is a hazard rate. So survival probability is always ranged from 0 to 1, because you know the probability, how do we define probability? That is, there is a numerator and there is a denominator. So in numerator, we take the probability that event happening, and in denominator, we take the total possible outcome. So this Kaplan-Meier has got an advantage of life table, because here you have got the exact survival time. In life table, you have got the time interval. But in Kaplan-Meier, you have got an exact survival time. But in life table, there is no assumption. But in Kaplan-Meier, you have to have some assumptions. And it is more accurate in handling censoring data. Here you will get detailed survival estimate. And this is more accurate for small sample size, because for life table, you need a large sample size. And it has got more intuitive interpretation. So before we understand the concept of survival probability, I would like to tell you regarding what is a conditional probability. So don't think that it is something difficult concept. This conditional probability, the table or the life table or the Kaplan-Meier, it gives you automatically. You don't need to calculate it. We are just telling you because you should understand what is happening at the background of the analysis. That's why we are telling this. Otherwise, you don't need to calculate this conditional probability. So the conditional probability is a probability in context of a Kaplan-Meier survival analysis. It considers that if you have survived up till certain time point, what is the survival in the next time point? That means if you have survived till previous time point, what is the probability of survival beyond that time point? So let's consider this hypothetical example. So here the population, it is a hypothetical study, and the population which I am studying is the patient diagnosed with a certain type of cancer. And my interest is after I have diagnosed, the time till death. So if I have got the survival probability of all these 3 years, so the survival probability after first year is 80%, survival probability after second year is, let's say, 60%, and survival probability after 3 years is 50%. You get this from life table also. Now, what is a conditional probability? So if I have to calculate the conditional probability of a patient surviving the third year, given they have already survived the second year, and this is denoted by P. So this conditional probability is defined as, in the numerator, you will take the survival probability or the percentage for third year, and in denominator, you will take the second year. So if in the previous one, you know that the probability of surviving for 2 years is 60%, and the probability for surviving 3 years is, third year is 50%. So the conditional probability will be, as we have known, that it will be the survival probability in 3 years divided by 2 years. So it will be like 50 by 60. So it will be 83%. So we tell that it is the 83% of the survival probability, or 0.83 is the survival probability of the people in the third year who have already survived till second year. So this is the conditional probability. And the interpretation is, given a patient has already survived for 2 years, the probability that they will survive through the third year is approximately 83%. And this estimation of Kaplan-Meier cumulative probability is based on this conditional probability. So this is useful in understanding the chances of continued survival at each subsequent time point, given the survival up to a certain time. So what is this Kaplan-Meier? This is again one of the method of analyzing the survival data. It is also known as the product limit estimator, because it is the product of the conditional probability. So this is the ST, which we have seen earlier. This is the survival function. It is defined as the product of P1, P2, P3 till Pt. And this T is the time period of our follow-up or the total study duration. So this P1 is the probability of subject surviving at least 1 month after the beginning of the study. This P2 is the conditional probability of surviving the second month. Here I have taken the example of month. It depends what is the unit of measurement in your study, and the conditional probability will change accordingly. Like if you are measuring this in second, then it will be like first, second, something like that. Or if you are measuring it in year, this time will be changed by year. So this P2 is the conditional probability of surviving the second month after having survived in the first month. Similarly, this P3 will be the conditional probability of surviving the third month, already survived till second month. So such how you explain this Kaplan-Meier product limit estimator. And this we know as the cumulative probability. The probability which we have explained, the median estimation, the median survival time, where I have introduced one term which is the cumulative probability. So this basically this survival function is the cumulative probability of these products. So here in Kaplan-Meier, either we measure the overall time to event. That means it is not necessary that you split it in gender or any other variable, or you can compare it across any independent variable. Like we have seen previously also, we have compared it across the gender of the baby, male and female. So you can do that. This is again one hypothetical example of 6 patients analyzed by a Kaplan-Meier method. So suppose you start with this 6 patients initially in the beginning. So you followed that patient, and at 4 months, 1 patient died. So what will be the survival probability? So 1 patient died, so how many remained? So 5 remained. So my survival will be, probability will be 5 by 6. So it will be 0.833. Then again at 3 months, 1 died. Sorry, at 10 months, this is 10 months. So at 10 months, 1 person died. And this green one is the loss to follow-up. So what will be the survival probability? So 3 remained here. Because 1, there is a loss to follow-up. So I will reduce this 5, 1 loss to follow-up and 1 died. So 3 remained. So 3 by 4. Why 4? Because this 1, I will deduct it from the denominator, because this is a loss to follow-up. So the survival probability is 3 by 4, which is 0.754. So remember that here, in case of a calculation of a cumulative survival, the loss to follow-up or the censored cases, they are always deducted from the denominator. We'll see, because the Jamovi that does not give a survival table, I'll try to explain this from the SPSS. So this 3 by 4 you can see that this 3/4 is the survival probability. So what will be the cumulative survival? So remember, we have remembered that this Kaplan-Meier is the product estimator. That means it takes the cumulative survival. So it will be the initial survival multiplied by this survival. Because remember, we have discussed like P1, P2, P3. So this is the P1, this is the P2. So this 0.833 multiplied by 0.750. So this cumulative survival will be 0.625. So you can see that in survival curve, remember, we have learned that it is non-increasing. That means it will always decrease. So that's how you will see that the cumulative survival will keep on decreasing because you are multiplying two numbers which are less than 1. So if you multiply two numbers less than 1, it will again become smaller. Similarly here, at 14 months, one person died. So one person died, how many remained? 2. So 2, and then in denominator, this is 3. So 2 by 3, it is 0.677. So cumulative survival will be already, this is 0.625. So 0.625 multiplied by 0.667, it will be 0.417. And at 24 months, the one died and there's one lost to follow up. So again, if there is a 0 in numerator, it will be a 0. So overall probability will become 0. And the curve will touches the x-axis because now the cumulative survival probability is 0. So have you understood the concept of cumulative survival in this case? Remember this formula that this survival function ST is a product of all the probability like P1, P2, P3 and P4. And that's how we are keep on multiplying this probability with this one, then 0.625 with this one and so on. And this we plot over a graph, like on x-axis we take the time, on y-axis we plot the cumulative survival. So now how we compare the survival curve. So for different terms in a clinical study, you can have this comparison of this survival curve. Again, you can plot it across any risk factor. Like in this case, maybe you will see that in breastfeeding one, not as a risk factor, but if you want to see like what was the perception of women across that no milk or very high milk, you can plot a survival curve with more than 2 group where you will perform a pairwise comparison, or you can do it across whether in our case regarding the gender, which we have seen male or female, or education of female like no education versus the education or literate versus illiterate, or across gender. So in studies involving the comparison of two treatment, we at least need these 3 information. We need whether that particular serial number or study subjects belong to a treatment group or a intervention group like A or B, where A might be one placebo or other treatment, or there can be 2 treatment arm like A and B. We need the follow-up duration in days, and we need the event of interest, like whether that event occurred or not occurred, like 1 is the event occurred and 0 is the censored. So by this time, you know what is censoring, what is 1 and what is 0, what is the follow-up duration. Here, the duration is in days. Now, so that log rank also, that term you have seen when we were doing the life table analysis. So if you can see that there was a difference in the median survival time. The female has got a more survival time as compared to the male. But whether that was significant or not, how you will come to know. So for that, there are various statistical tests which are there in Jamovi also and in SPSS also. So the 3 most commonly is the log rank test. So log rank test, as you can remember L for L, it is basically when you want to compare the survival probability in the later part of the time period, then you use the log rank test. Breslau test is used when you want to compare it in early period. And this Breslau is also known as the Wilcoxon test. And this Taron-Wire test, it is used when you want to compare it in the middle part of the graph or the survival curve, then you should use Taron-Meier test. Taron-Meier. So like, for example, this is a heart attack, a patient receiving treatment A, and what is the estimated probability that following a first year, attack will survive for more than 3 years? So answer such questions, we need survival analysis. So what is a median survival time? Although we have touched this concept, but again, I will repeat it. This median is not the traditional median which we read in the descriptive. That's why here you will see that it is there with the confidence interval. So this median is the cumulative probability. So it is the event time or where it is the time where the cumulative survival becomes 0.5 or 50%. So you can say like in the previous one, you have seen that if let's say 89 days was the median survival time for male baby. So how will you write? That means 50% of the male baby, they stop the taking exclusively breast milk by 90 days. That means they were exclusively breastfed till 90 days. So that is the median survival time. So some basic concepts related to this Kaplan-Meier is, it is a non-parametric method to estimate survival function. And we have seen initially that this time to event data is a non-parametric skewed because it varies from 1 day till as long as the period of follow-up. So it is non-parametric. That's why Kaplan-Meier estimation method is a non-parametric, or many people call it as a semi-parametric also. And it is also known as the Kaplan-Meier product limit estimator method. And it can accommodate missing data such as censoring, which we have seen. And here median, standard error of median, and the confidence interval of survival time is calculated. And here we can compare the survival curve using log rank test or Breslau's test or Taron-Meier test. So why it is unique time to event data? Because outcome, we say that it is not only the event, but when that outcome has occurred. And we have seen that logistic and linear regression is not suitable, that does not have time. It tackles the special type of missing data, which is the censoring, and it uses the partial information also. That censoring, we know that exact survival time is not known, but still it incorporates that from that multiple time point. Now, there are some issues in the time to event data. So you should have a clear-cut definition of target event. You should have start and time on time scale. We have seen this. So now coming to the Kaplan-Meier, what are the underlying assumptions? So the underlying assumption, the first is the event state. This should have two mutually exclusive and collectively exhaustive states. That means censored or event. So all the data set, like I said, all the people or the study subject either should have 1 or 0. No one can have, except for 1 or 0, any other thing. The second is the time to event or a censorship, which is known as a survival time, that should be clearly defined and precisely measured. And the third is there should be independence of censoring and the event. This is one assumption. That means those of the people who were lost to follow up or who withdrew from the study, that reason of the censoring should not be same as event. Like in this case, the censored babies whom we did not have a true follow-up time or a true survival time, we assume that they did not they were not censored because there was a cessation of breastfeeding in those people. So those individuals who got censored, the reason of censoring should be different from that event which we are studying. And that is one assumption. Otherwise, the observed survival time will never be accurate. So this is one assumption which we check. The next is your left censoring should be avoided. So how you can avoid left censoring? So in this case, since the breastfeeding, so by frequent calling them, or maybe if you have got some technique where you can have a real-time data, so that left censoring should be avoided. And you assume that there is very minimal or no left censoring. The another concept is the secular trends. or there should be no secular changes. I'll explain that in detail. And then the next thing is there should be similar amount and pattern of censorship per group. So in SPSS statistics, there is a separate way to do this. In Jamovi, I'll tell you how to do this. Similar amount means there should not be too much difference across two groups in the amount of censorship and the pattern of censorship. So now what do we mean by the secular trend in the survival analysis? So the secular trend is something like with time, if there is some change in the treatment or screening procedure. So this is one of the assumption of Kaplan-Meier, that there should be no secular trends, and it is also known as the secular changes. So if there are long-term, because we know that survival time is there for if follow-up time is for 5 years. So there can be some changes in the survival data. And if we recognize those trends, that is crucial for the accurate interpretation. Because in long duration, the study may span for many years. So patients, they typically enter in study at different time points. So let's say example of a skin carcinoma. You want to see the survival of people after they have been diagnosed with skin cancer. So changes might happen. So if you start a study with 500 skin cancer patient, in recruitment period, you have recruited the participants over several months. So each of them have their own diagnosis day. So what happens, like after 1 year, if there is some new treatment which has come up and now the mortality has decreased. So now the patient which you have taken, they will have less of mortality. That means there will be increased right censoring. What is right censoring? Right censoring means that the observed survival time is less than the true survival time. So due to the improvement in treatment over time, the more participants will survive longer, delaying the occurrence of the event of interest, which is the death. And then if there is some screening procedure which has been developed, so now you can diagnose the skin cancer at an earlier stage. So you will reduce the left censoring. So you assume that there is no secular trend during your study period. If there is such secular trend in your study period, how to do that? So you will do the separate analysis before that time point and after that time point. The researchers should be aware of that potential secular trends. There are statistical adjustment, which are there to account for these methods, which we call it as a time-dependent covariate. But right now we are not going into that. For you people, you assume that there is no secular trend between your study duration. That's one of the assumption which you have to make out and you have to write also. So if there is a secular change, there should be analysis of two different time points. Like if the different treatment modality the patient started taking after 1 year, then you will analyze that before 1 year time differently and after 1 year separately. So now we'll see the data set. So before we see the data set for Kaplan-Meier estimation, I would like to explain this table. But there is a problem in Jamovi that you don't get this background table here. So this is, I have taken it, should I tell them or should I leave? I think I should leave it because I have told you the concept of cumulative survival. I'm not telling you right now. Maybe if time permits, we can tell you, you people tomorrow, because right now I would like to tell you the concept over the Jamovi, how to perform this Kaplan-Meier. So I'll go to this again. If you see the question is again the same. Data set is also the same. I have to use the survival time. I have to show Kaplan-Meier. I have to perform this Kaplan-Meier analysis to estimate the survival curve and compare it for the different level of categorical variable like gender, marital status, skin-to-skin contact, and milk production perception. So gender, marital status, skin to skin, and milk production. So I'll go to this jam movie. And here, till now, we have used this option. The survival one, the univariate survival. But for Kaplan-Meier, this death watch is better. I'll show you. So click on this survival analysis. You can run both the option, but I'll show you what is the advantage and disadvantage of both the option. So right now I'm telling you with this one, the death watch. So here I will enter the time elapsed. This event is here. You have all done this. That's why I'm doing it fast. Termination. So even if you don't enter groups here, it will give you the overall survival. So in case of this survival module, which you see here, survival analysis, you get an overall survival also. So overall survival, if you see the median survival time, it tells you the 90 days. Means if you don't want to break it into gender or any other groups, here I have not entered any group, then also it is giving me the overall survival. With a median survival time, 84 days, the lower boundary, and 108 days, the upper boundary. If you want to like put a censored event, if you click that, so censoring is what? Censoring is shown by these cut points. Can you see there is a slash, there's a vertical small lines. So these are the cases which are censored. If you want a risk table, it will give you the risk table or the risk set. So now you can see it is a risk set at each time point, and since it is all, so it is not like breaking it into male and female or any categories. So at 30 days, 200 people survive. Then at 150, then 60 days, 154, 90 days, 97, 120, and 150, 180. Like this. So you can calculate the cumulative survival also from this. Like 154 by 200 will be one survival, then 97 by 154 will be another. And if you multiply these two, you will get a cumulative survival here. Those of you who are interested, you can do that. Otherwise, no need to do because software has already done it. So this is the risk set of individual, number at risk. And this is your overall survival. Now coming to if you want it across any group, like in the study question, it was written like gender. So then you can enter this gender here. And then you can see this graph will be, it gets split into two. So now you can see this gets split into two along with censor. Right now I'm unchecking this censored because this will have a smooth, better graph. And then you can perform log rank here. So this we have seen earlier that if log rank does the later part, but the value of log rank, you can see that this is not significant. In the initial, we have seen that it is p-value is 0.2. So this is not significant. Other tests also you can write like Gehan and Taron, where again, you should not do like you don't do this like click all and see like what is the significant. No, if the log rank is not significant, the other will also not become significant. You will see that other p-value is higher than the log rank. So log rank is most commonly reported and most commonly done. And here you will again see the same thing which you have seen earlier, that the median survival is 89 days and 106 days for male and female. This is for gender. Now, if you want to compare it across some other group like marital status, so I will enter this marital status here. So marital status, you can see, if you see the value of log rank, you will see here that it was significant across the marital status. Can you see? The log rank, the p-value is 0.015. And by graph also you can see that this is quite wide as compared to the previous one. This is risk set for this. And if you see here, this is the median survival time. So this is single. Single means marital status means married and other are like means not married, single and maybe not. And then you can see that the others are like this is 118 days and this is 80 days. Means the median survival for a single one, that means ki a person who are not married, that is 80 days, and survival is more in other. And here if you see the curve which is upper, that has got more survival time. Definitely at the last it has come down, but you will see that it has survived. The cumulative survival is more. And how will you calculate this cumulative, this median survival? Here, since it is in the background, you can say that there's a graph. So this 0.5, if you trace this, it is touching here. And then if you draw a vertical line like this, it will be like, this is 50 and 60, so this probably 75. So you can see that the days, the median survival, it is already calculated, this is 80 days. Similarly, for others, you can see. So the median survival is again where the cumulative survival probability becomes 0.5. If you draw a line, touch this graph and draw a vertical line towards this time, then you can see that this is the median survival time. Now coming to another across the perception of milk, whether I have got no milk or little milk. So this is the milk production. If I enter this here, so you will see that there are 4 graphs. Yes. So can you see there are 4 graphs and 4 risk set, and with the median survival, you can see that this is your median estimate. So this is showing you the censored and observed and expected event. And this is your median survival time. So median survival time is, there are 5 categories here. So it is largest, it is the 132 days. And here you can see that means the ladies who had got that I have milk production which is more than enough, there the cessation of breast milk or the exclusive breast milk happened at 132 days. So it was the largest among all. And similarly, you can do the pair-wise comparison. So this, can you see there is an option of pair-wise comparison here? So this option is used when you have got 3 or more groups. Since I have got 3 or more groups, here there are 5 groups. So you can click this and you can see how it appears. So if you see this, the analysis of difference log rank, it is showing yes, it is significant. Median you have seen. And then you can see overall also you have seen that this is the overall significance 0.001. And then you can see that it gives you pairwise, means between enough and little, between enough and moderate, enough and more than enough. That means with enough, it will compare these 3, 4. With little, it will compare these 3, and with moderate, with 2 and some. It has performed, and you can see the p-value. So you can see this all is significant, but this is not significant between little and moderate. If you see, these 2 values are not significant. This is not significant. So you can write that the difference between moderate and more than enough, and between moderate and little and more than enough, these 3 are not significant. Rest all are significant. So this was a pairwise comparison. It is a graph, and you can see it plots the median survival automatically here, because I have clicked this medians. That is a median survival time. So yes, I think one Tapobrata or someone asked regarding how I drew that line. So there in that curve, it was not possible. But here you will see that if you click this medians, this draws the median survival time by this dashed line. Can you see, Tapobrata? I don't know whether you are here or
Yes,
not.
ma'am. Yes, ma'am. Thank you so much.
So is it clear to you that how to compare across group overall? If you want overall, if you move this back, and this is the interpretation, you can write it if there are more than 4 groups. So how to write the interpretation? So you can see that I have copy pasted the same table here. And not this time, there's a live table. Yes, this one. This is the Kaplan-Meier curve for median survival time. So median is, for if I compare it across the gender, then 106 and 89. This was the various tests and statistical report only one, although we have pasted all the 4. But log rank is the most commonly done. In here, you will express the 95% confidence interval, and then you will show the graph here and the risk set. And then you can write that the Kaplan-Meier survival curve, it was comparing the median survival time for exclusive breastfeeding based on gender. You will write that the analysis revealed that among female infants, the median survival time for exclusive breastfeeding was 106 days, with 95% confidence from 82 to 132. In contrast, the male infants' median survival time is slightly shorter. And then again, I have written, one of you can read this. Yes, any volunteer who can read this section? I think Dr. Tapobrata can do that.
Yes, ma'am. The differences in median survival times between these 2 groups were
Can you read
further
this?
assessed. Yes, ma'am. Can you hear, ma'am? The differences in median survival times between these 2 groups were further assessed using various statistical tests. The results indicate that there is no statistically significant difference in the median survival times for exclusive breastfeeding between females and male infants. The p-values for the log rank is 0.200. For Gehan, it is 0.310, and for Tarunware, it is 0.321. And the Peto, it is 0.233. Tests all exceed the conventional significance level of 0.05. Therefore, based on these analyses, it can be concluded that the gender of the baby doesn't significantly influence the median survival time for exclusive breastfeeding among women. Mothers of both females and male infants appear to have similar breastfeeding durations.
So this was, thank you so much. So this was the one of the interpretation. Now, if like this is for the other, like single mother, I mean single, this marital status means single means unmarried and other means like married. And this was the median survival, but it was significant. So you will see that here, the same sort of write-up I have written, but here that you can see that, therefore, based on this analysis, it can be concluded that marital status significantly influenced the median survival time for exclusive breastfeeding, especially the unmarried mothers. Single mother tend to have a shorter median duration of exclusive breastfeeding compared to other marital status, means married or divorced or whatever. So this was the, and then again, this was the pairwise comparison. No, this was something a pairwise, I think we have not pasted here. This was again, when I was showing you how to copy paste the survival, this is that. When I was showing you how to like copy the result from here. This one. So you know by this time that you have to go to right click, copy it and paste it. So is it clear for all of you? Any ambiguity? I have not told you specifically the in survival table that I'll show you tomorrow, because the Jamovi doesn't give you the output, the survival table. We'll see it in SPSS just as for understanding tomorrow. And then again, we'll redo this. But till this time, are you people able to understand the concept of all these? Any confusion up till this point? Or do you want anything to be repeated? Yeah, recording, Sarojini, you will get the recording of today's session by, I think, today 9:30, 8:39 you will get it, recording. Okay, Tapoprata is saying to some extent. Okay, so yes, maybe if you do it repeatedly, you will understand this. Maybe, have you understood this survival? That means, what do we understand by this? Like median survival, there are some take-home messages like there's a cumulative probability, there is a median survival time, there's a 95% confidence interval, how this time to event data. I have deliberately not told you two concepts till now, which was the pattern and amount of censorship. I'll tell this tomorrow because you need to have some basics of Jamovi to perform this. So first you get comfortable till today's session. Again, we'll begin with the Kaplan Meier tomorrow, because I have not told you how to check for assumptions regarding the amount and the pattern of censorship data. That I'll tell you tomorrow. So to some extent, maybe what about the other people? Have you understood something out of today's session? The breakout room for this session, we'll start tomorrow, because right now it's 5 and I think we can keep the breakout room for Kaplan Meier tomorrow. So we'll start with the few revision concepts tomorrow in the morning. Like today, tomorrow at 2 p.m. we'll start with some again revision of this today's session, and then we will go to the breakout room. Is it okay? In the meantime, we have shared the article with you people to try to read that article, and you have got the data set because we have created that data set based on that article. So go and see the analysis, how they have written, and you are performing the analysis. Then you will have some feel of this survival analysis. Is it okay to all of you? I think okay, Tapoprata is writing okay. I don't know what about other people. Prashant is also written. So if you can tell the assumptions of, yes, I'll tell. I have not told you KM completely today because this can be done. I have told you only with this option of, you can see this, this one. You can perform this using this univariate survival also. So yes, I will tell Prashant tomorrow again, Kaplan Meier with assumptions and using this option, univariate survival. And because I have only told you this death watch, okay, little. We'll revise this everything tomorrow once again. Then we'll learn. But there's a task. Please go and read that article. Unless and until you read that article, then you will not be able to, corroborate the findings. The findings are maybe slightly different from what we have given you, like data set. So you read the article twice or thrice, and then again perform the analysis. What we have done today, like we have done life table, and we have done the median survival, like little bit, just do that. And then again, if possible, tomorrow morning, listen to this recording in 2x probably, because the normal speed, it will take time. But if you can listen it in 1.5 or 2x, then it will be covered very quickly. And then we'll again meet tomorrow at 2. Okay, then should we conclude the session?
Yes, ma'am.
Yes.
Thank you, ma'am.
And thanks a lot, ma'am. Thanks a lot.
Thank you. Thank you. Thank you, everyone. So see you tomorrow at 2 p.m.